In this video, we're going to cover the LAN-Caster server code. That is probably the code you're going to have to work with the most developing your own game, and the things you're going to want to subclass. And we'll do a little bit more than that. We'll actually start right from the beginning of how the server starts and how it gets configured right through a little bit to the server map and how then you might want to subclass it. Did a similar video on the client side, so if you want to check that video for the client and how it starts. So let's just start by at the beginning. So if we go look at, let me just get rid of that. Let's just start right here at the run demo bat. So this is the Windows file that shows how the server gets started. So we have our Python command that runs the startserver.py. So the startserver.py script, so I'm going to go into the LAN-Caster source directory. Startserver.py is the script responsible for firing up the server and getting it running. It basically only has two jobs. The first one is to handle all the command line arguments. These are all the arguments you'll see if you do the startserver-h to get the help message. And it's going to parse those arguments here. And then it's going to effectively load the server class itself, or the server module. Now, we use a fancy load module piece of code here. What this will do, it will look for a server.py in the game folder, and if it's not there, it'll use the server.py from the engine folder. So it's going to do that, it's going to run the init, and then we're actually going to call the run command there, which is a forever loop that will run the server. So let's just start here. Now, I'm going to assume that we're just going to look at the engine module itself, and we can look at subclassing it later. So if I go back to the source directory of LAN-Caster and into the engine folder, I will see a server.py. Let me just double click that so it stays up. So within this, the main class is called server. I'm not going to read all the things or all the details to you. You're welcome to read all that. But I'm just going to look at the init function for a moment just to walk through with you what it does. And it does several things. The first one, it does create a global variable and stores itself in the global variable. This is used in a few small places throughout LAN-Caster that if the code in the server needs to find the actual instance of the server class, and there can only be one of this particular object type, that it can do that. So that's what the global variable is for. There's only a few small cases where that's required, but in general, you won't need that. But it is something that's there for some specific uses. I'll skip over some of the other stuff. It will store some of those arguments in the object that came from the command line. So it stores the ones that it wants. Just running through, yeah, sets up some of the basic things. I'm not going to go through this in huge detail, but what I want to do is just show that, beyond that initial setup, the next thing we do is all the networking setup. So we get ourselves all set up for networking. We make sure that we've opened our socket. Now, the server initially doesn't send any messages to anyone in a normal local area network setup because it's going to wait for clients to connect to it. There is something called a connector for running over the internet that's a little bit different, but I'm not going to cover that right now. So basically, we get our socket open. And then we load our tile sets and we load our maps. So we have loaders for both of those, and those will load all those up into RAM for the server. And the maps here are going to be of type ServerMap Class, where when we saw the client, they were a type client map. So here, because we're specifying map type here, we'll actually get ServerMap classes. So a different subclass of the map. So we've got our network up and running. We've loaded our tile sets and our maps. And this is the next thing that we're going to do in the init is when we load the maps, we're going to look for any sprites that are of type equals player. So we're going to go through all of the maps we just loaded and find all the player sprites. So if we find 4 player sprites, there's going to be a 4-player type game. We're going to allow 4 players to join the game, and we'll randomly assign them to those player sprites when they join. So this is the piece of code in the server init that actually goes out, finds those. Once it finds them, it actually shuffles them so that each time the game starts, it would be more random which players get assigned to which sprites, different starting locations. And that's it for the init. So we grab a bunch of the parameters, we set up the networking, we load tile sets and maps, and then from the maps we look for where the player locations are to allow them to join. So server startup fairly straightforward. The next thing that happens, if we go back to our startserver.py and we go have a look, so that init would have been run when we ran the loader, and we get our modules, which is going to be our server module, and then we run it. So we actually call the run method. So the run method is the loop that just kind of goes on forever. So it's a while true loop, and it has several jobs. The first one here is to receive any messages from clients and reply to those messages. And then it does something called stepping the server forward. And then it sends any updates to clients that, if a map has changed that the player's on, it sends what's called a step message with all that new data back to the client. I'm going to skip this one. This one is for communicating over the internet. So that's going to send keep alive messages for that. We're not going to worry about that. And then the rest of the code here is really about making sure this loop runs at a particular rate or a number of steps per second or frames per second. So if our server is set to run at 30 frames per second, this loop will try to run specifically at exactly 30 times per second. So 30 times per second, it's going to check for messages from clients. It's going to move the server forward one step, or move the game forward one step, the game logic. It's going to send any updates to clients, and those clients will, if this loop's running 30 times a second, those clients will get 30 of these messages a second. They'll be able to display 30 new frames per second to the player. And then we go back and do that loop again and again and again. So just to talk a little bit about some of the main ways that this works, the receive reply messages, there's two key messages that we want to receive. The first one is clients trying to join the game. And the second one is user input, when the user has clicked the mouse and they want to move or they want to take an action. So the way those work is the client will send messages of different type. And if I look in my messages.py file here, this will define the valid message types. So we can see that a client can send a join request, and they can say what game they want to join with the player display name. And then the server would send back a join reply. Or the player could send a player move. The server doesn't send anything back if it gets that message type. Player action, again, the server doesn't send anything back. So let's just have a quick look at what the code for that looks like. So when the server calls this function here, this method, this will actually call other methods inside this server.py. And again, I'm telling you all this because you can subclass this, and it's designed to be subclass. So you can add new behavior to the way these messages are handled. So if we scroll down, we'll see the networking for game messages. So if a client were to send a join request message, this method would be called. And these message names just match the name of the message type. And here you can see what the server does when it gets a join request message. I'm not going to go into all the detail, but you can read through that if you want. There's some comments that walk you through it. And if the player wants to move, this is the function that would handle a player moving, or if a player requests an action. So we have a message player action. This method would be called. There's some other ones for test messages and things. So that's the primary networking messages that the server can handle. Joining, moving, and requesting action. You can add others, that's fine. You just need to extend several things. I'm not going to go into all the details of how to extend to add new networking, but you can certainly add to that functionality by subclassing the server. The next thing, after processing all the messages from clients, the next thing the server does is it takes a step. So a step is moving the game forward in time. So if we have a game that's running at 30 steps per second, let's say, that's the default. It can be higher or lower, it's fine. If it's running at 30 steps per second, then let's say a player's walking across the map. And let's say they're supposed to be walking at 20, let's make this easy on myself. Let's say they're supposed to be walking at 60 pixels per second. And I know that I'm doing 30 steps per second. That means that player should move 2 pixels. So this step forward in time would move that player 2 pixels, okay? Because they're trying to move 60 per second, and I'm doing 1/30th of a second, that's 2 pixels. So that's what that step server does. I'm going to look a little bit at the details of this now, but there's actually going to be a whole nother video on how stepping happens. But I'm just going to go look at step server. Actually, I'll just search for it because there's a bunch of code below there. So if I go find, yeah, so the step server. So the step server does several things. The first thing it does is it does kind of global game logic stepping. Whoops, I just lost what I was searching for. Step server, and let me just make this so it doesn't do anything. Okay. So the first thing it does here is global game logic. So this would be logic, this function call, which you can extend for sure or override. It will check to see if the game is ended, for instance, or anything like that. Anything that's global game logic, logic that doesn't apply to a single map. You can see how the demo uses this and how it subclasses it. But here you'll see that in the server.py right now, it's just a pass. It doesn't do anything. So this is definitely something that you'd want to override or extend for your particular game. And then what step server does is going to, for each map, or for each player, if the player's on the map, it actually calls step map. So it finds all the players and all the maps that have players on them, and then for each of those maps calls step map once. So if there's 3 players on a map, that map just gets stepped once. If there's 3 players and they're all on different maps, each of those maps would get called. Maps that are not don't have any players on them don't get stepped, and this is just to save CPU time. So that's the step method. Again, there'll be another video on some of the deeper details of that, but that's the basics of stepping forward in time. Let me go back to the run method. There we go. So far we've received messages from the clients and processed those. We've stepped maps forward. And now what we need to do is send step messages. So during that step forward in time, things have changed. And what we need to do, and I'll find this one right here. Find step message. There we go. Okay. So what this will do is for each player, it's going to find out what map that player's on. If the map has changed, okay, so as we step forward, it detects and stores whether or not maps have changed. If the map has changed, it's actually going to send a message to the player with their updated map. And just so you see what that looks like, there's a function called getStepMessage that actually generates that step message. And it's just a Python dictionary with these parameters in it, and it might add in a couple other parameters. But this needs to match the message format for a step. So if we go look in messages.py, we'll see this is the definition of a step message and the types it can have. And then we can look and we can see that the server is doing that correctly. So that's generating a step message and sending it back to the client. Go back up to the run. So we've processed the network messages, we've taken a step forward, we sent those updates to the players if they're on a map that's changed. I'm going to skip the next one here. And then we are, again, in this code that waits. So this code, again, is just to time that, to make sure that we are taking exactly 30 steps per second. You can read through this code. I mean, it's not rocket science, but it is a bit of gobbledygook to make sure that that timing works well. The core part of this code is how long to sleep. So we do have a call to sleep. So if we get down in this code, the server will actually go to sleep for a very short period of time and then wake up when the next step should start. Okay, so that's the basics of the server and its main loop and what's happening in that loop. Now, the interesting thing here is really what's happening in the server class. During this step processing, what's going to happen is each map is going to be stepped forward. And this is really the magic that makes the game work. So if we go into ServerMap, what we see is a bunch of game mechanics. Now, this doesn't directly implement the map step. It's actually something called the step map class. And we actually subclass from that. But what is in the server map is all the things that happen during a step. And these are what we call mechanics. And what we want to do is just talk just a little bit about these mechanics without getting into all the details, because we'll do that in a later video, and especially when we dive into the engine test and the demo. But these are the default mechanics, and you can read them here as to what they are. And then when you get into the code itself, you can see this is the move linear mechanic. So this is the mechanic that moves a sprite. So a sprite set up to walk across the map. Here's the code that does it. So there's the main piece of code that does that. And there's a setter to set their movement, and something to stop their movement, to delete their movement. The map door mechanic, this again is the mechanic that takes you from one map to another. So initialize it when a trigger goes off, and I'll talk about all this when I talk about the mechanics in detail. There's the code for that. So each mechanic is divided up into these sections. And this is something you can subclass to add your own mechanics. So let's talk about subclassing a bit. So if we look at the demo, and we go just within the demo folder, we will see both a server and a ServerMap file. So if I look at the server, I see that it has subclassed from the engine server. And so it's extended the init. So it's doing a few other things to add the idea of waiting for all players to join. So the LAN-Caster engine by itself, it doesn't care whether or not all the players have joined the game before the game starts. That's something that is really game dependent. What does that mean? It's really up to the game. So here we have the demo setting up the idea of I'm in mode waiting for players. And you can read through this code and kind of get a better understanding of some of that. And then it also extends receiving the message for a player move. So when a player moves, I want to make sure that marquee text is cleared from the beginning. So when you first join the demo, there's the marquee text that pops up. And maybe I'll just do that right now. So run demo. And then as soon as the player moves, and maybe I'll get two players up here. If one of the my marquee text vanishes, and when this player moves, their marquee text vanishes. More on that in the engine test demo. But that is something that we do in the code. So we've extended that message saying, hey, when we receive a message, once a player is moved, we want to make sure that we delete the marquee text for the player, assuming we're in the right mode in those things. And the same for player action. We don't allow player actions while we're waiting for other players to join. And that's there as well for the movement. We don't allow the player to move until we're waiting for other players to join. When we add a player, we do a few extra things about popping up the marquee text saying, hey, we're still waiting for 2 players more, those sorts of things. So we've extended. So there's several pieces we've extended. And this is the key thing that we've extended here is the step server start. So remember I said that with the stepping, there was a global game logic that exists, and it was just empty in the engine's server code. So here we are, and we want to check to see if the game has been won or not. And so this is basically checking to see if all players are within the stone circle. And I won't go into the details of the code again, but just to understand that that's what this code is here to do. And if in fact, we are inside the stone circle, then it actually changes the game mode to game over and these sorts of things. So you can read through this and understand kind of the details of what's happening there. But this is the code in the server that detects, hey, the entire game is over. So it's not logic applying to one map, it's applying to the whole game. That lives in the server.py. Okay. So logic that applies to a single map, you actually put that, especially the game mechanics, that applies to what we call ServerMap. So ServerMap here, we're subclassing from the engine as well. So engine, ServerMap, we're subclassing that in the demo ServerMap.py. And I'm adding new mechanics. So the bomb, the ability to throw things, the walking through mud is actually a speed multiplier. The chickens walking around. The respawn point, which is actually used by the saws, it's not obvious which one this is, and I'll talk about that more in the demo, but all of these mechanics get added. And just like we saw with the previous file, each of these mechanics is well divided into a section. So the bomb area has an init for it. It has a trigger section. The throwing has a init, a trigger. It has a check location override, several things. I'm not going into the details of this. This is just an overview of this code. So that's the basics of those and how you can want to subclass them. Now, one special thing is you can have game mechanics that are specific only to one map. So if I look in the demo and I look in the under and I look in server map, I see that the saw is so the saw trap is only here. So I couldn't add a saw trap right now to say one of the other maps. I would have to either take this code and copy it into that map folder as well, because now I'm in the demo maps under server.map.py file. So this code only applies to the under map. Now, the nice thing is that if there's a bug in this code, it's only going to affect that map, but the downside is you can only use it in this map. So you can either have your game mechanics apply to the entire game by putting them in the game folder or to only a specific map. And again, the format's exactly the same, and I'll talk more about that. Okay, so that's how to subclass and the basic setup.